Welcome everyone to the lecture for week 3 of game asset creation. So just to recap, the first week was just a general overview of where the course was heading and a quick look at Blender and the UI. Week 2 we looked at modeling. That was mostly focused on the modeling tools and specifically how to use those tools, but not necessarily much about how to actually make a specific model that you're after. So it was very technical. This week we're going to focus a lot more on what makes a good model and specifically what makes a good model for a game engine. So as you'll see from the scene here in front of me, I have 3 candlesticks that for the most part look pretty much the same. This one on the right here is obviously got more detail on it than the other two. But for starters, we will just select that one, H for hide, and have a look at this central candlestick here. So this is the example of the good model. This file will be available for students to have a look at. If you look at the course information booklet page, there will be links for the file provided. So first of all, the poly count. Keep in mind that poly often refers to a quad, whereas once it gets into a game engine, it will be split into triangles. So if your model is entirely made of quads, you can see here that I have 283 faces, but there are 535 triangles. That is because the triangle count is obviously taking each square quad that I've got and splitting it in 2. Technically speaking, we don't need to worry about that a huge amount, but the triangle count is definitely the more accurate count of the two in terms of people referring to a poly count in a game engine. So being a relatively small object, a candlestick, the player is never going to get particularly close to it unless it's a collected artifact in a game where you sort of zoom into it in a separate menu and then can rotate around it up close as I'm doing now. So 500 polys, 500 tries in this case, is sort of an acceptable amount. This could obviously be a much more detailed candlestick depending on what the art style is and all the rest of it. But it's important to note that there isn't really a 5,000 polys is a good model, 8,000 polys is a bad model. Sort of, there's no hard limits for that sort of thing. It comes down to a number of factors, like I said already, one of them being how close is the player going to get to the object. If it's a particularly small object on screen and it's never going to be bigger than 30 pixels high or something, this would probably be excessive, too many polygons. If, however, the art style dictated that this needed to have a lot more going on with the handle, then you would need to put a lot more detail into the handle to best represent what the art director wants for that model. Also important to note, regardless of how close the player is getting to it or not, how many objects are in the scene in total. If there is just an empty room, no windows showing any outside geometry, with one table and one candlestick on it, you've probably got a much better budget allowed than if it was a candlestick in the middle of a gigantic library and there's dozens and dozens of these candlesticks, as well as hundreds of thousands of books and props and scrolls and all sorts of things. So keeping the end result in mind is very, very key to figuring out what sort of poly count would be acceptable for a model. Another factor to keep in mind for the poly count is the end platform. If you're putting something on mobile versus putting something on a high-powered PC with multiple graphics cards lashed together, then that is going to have a difference as well. Important to put together a bit of a test scene for your future game projects and just check performance and then triple the amount of objects and check the performance and get a feel for your project and your intended platform and go from there. So let's say you've checked all those various factors and you know that around 500 polys for your particular object is a good budget. How do you use those effectively? So one of the key things with a model, particularly for a game engine, is the silhouette of the object. So as you can see along the center of the candle, these are long, thin polygons. Generally speaking, you want to keep a fairly even distribution of polygons, like on the dish here, but in this particular instance, the candle is a long, thin object, so long, thin polygons are fine. If, for example, we wanted to have a bit more of a change in shape for these polygons, select an edge, Control R to cut an edge loop, slide that down, scale it up. So there's now a little bit of a bulge at the end of the candle. However, this is probably all you're ever going to need to do for a shape like this at this sort of a poly count. Any other detail to the shape of the candle, so making it look a little more irregular, a little more melted, most of that is probably going to come through in the normal map. So when I mention the silhouette of the model, that is literally the orange that we've got here. That is the outline of the shape of the model. So candle being long and thin doesn't really need a whole lot of edge loops going down, because that would basically just be a waste of polys, because we're expecting it to be a thin shape on the edge anyway. Similarly, with the dish, most of the edge loops going in towards the center, so the edge loops that make it round. Again, there could be much more of these to give it a much smoother surface, but it depends on how close you're going to get to the model as to whether that is enough loops. There are a few loops going up the side, but because this is a much more gradual curve, we don't need nearly as many polygons to show that. Also, on the base of the mesh, you can see I've combined some of the polygons down, and then the bottom itself, instead of being, much more of a ring of triangles that go straight in, this is a much simpler shape created of just the 1, 2, 3, 4, 5, 6 triangles instead, which is a more efficient way to do it. It's the base of the candlestick holder. It's probably going to be against the table anyway. The player is not going to see it, so the more polygons you can take out of this area, the better. Also worth mentioning with this particular model, if we Alt left click on the various edge loops, we can select them very easily, but that's because there is a continuous loop of faces and a continuous loop of edges. You want that wherever possible. Don't necessarily have it at the expense of putting in polygons you don't need, but in terms of a workflow, it keeps things much simpler and easier to change down the line. So if we decided this is an interior line, we don't really need to see it that much, we can then do X, edge loops, and just simply remove that and keep editing with our model. This is also important for if you have a model that needs to deform. So common example would be a character along the arm. If you have nice edge flow of edge loops and loops of polygons going down the arm, when the arm needs to bend, it will bend correctly. However, if it's a mess of triangles, you will get oddness when you sort of go to deform that. Once again, we'll not really be covering rigging in this course, but if you're creating assets, you need to be aware of what those assets are being used for further down the pipeline. So if they're handed on to a rigger and then an animator, you've only had to deal with the model, but you need to know that the model is going to behave in whatever circumstances it needs to be in the actual game engine. Also worth noting, the pivot point, the little yellow dot in the center there, is in the exact center of the mesh. So it's very much at the bottom of the mesh and it's at the center of the mesh. Sensible pivot points also makes a big difference in a game engine, just in terms of how those objects are then placed, so the designers can place them around and it's just easier to manage and maintain. Whether the objects need to have any sort of rigid body physics applied to them. When the object is taken into a texture painting program or a sculpting program, if the pivot point is, off to the side or doesn't make sense, or the symmetry doesn't line up, all the symmetry tools in that software down the line won't work either, because the model is not technically symmetrical. It may be an actual symmetrical model, but if the pivot point is where the axis of symmetry is defined for the X, Y, and Z, it just won't behave properly, so keep an eye on that as well. Another thing to keep in mind for this particular model are the smoothing groups. So smoothing groups can be done a number of different ways, and unfortunately they're handled a number of different ways in various software packages. So if you're going between Blender and Maya, or Maya and Unreal, or Blender and Unity, you will need to double check how that handles going from one package to another. It is possible to select edge loops and apply this needs to be a sharp edge, this needs to be a soft transition. If that all works between the software package you're using, say Blender, and it also translates into Unreal, that's fine. The safer way to do it is all of these faces are currently set to smooth. If I was to deselect those, Alt A, go to face mode, hit L to select a continuous part of the mesh, you'll see what I've actually done is I've split that into different sections. So this particular section is all smooth within itself. As soon as it hits an edge that needs to be sharp, I've split that edge off. So whilst this will give you the same amount of polygons, it will increase the number of vertices that you've got going on. Not really a huge deal, but this is arguably the safest way to make sure smoothing groups are preserved between one piece of software and the next. Again, that is something to worth checking depending on what your end application is. Again, if this model was needing to be animated, that's also probably not a good way to do it, because if the bone needs to move, it'll make the weight painting more difficult. Because the weight painter will then have to worry about the vertex going this way and then the vertex going this way, because there's two of them at the same location. So for this model, it's fine. It's not going to move or be animated, and the smoothing transitions are pretty simple between the two. If you set the entire model to smooth and then take the high poly and bake the normal map from one to the other, that's also fine, because the baked normal map will be handling the bulk of the detail between which areas are smooth, which areas are flat, and any sort of small bevels or transitions between the two. So now if we unhide the other candlesticks, we'll have a look at this one. Maybe just hide the sculpted one for now. So at a glance, there's slight differences between the two. But when we jump into the actual mesh of this one, we'll see some pretty drastic differences going on. So select that one, hide it as well. Numpad, full stop. Something that I've also neglected to mention before is the numpad, if you have one on your particular keyboard. Numpad 1 will be a front view, 3 will be a side view, 7 will be a top view, and 5 will switch between orthographic and perspective. So those are the hotkeys for those. However, if we were to jump into edit mode here, we will see that there is all sorts of things going on with this particular model. So firstly, as I was mentioning about the silhouette, there are a whole stack of edge loops going up the long thin part of the candle that when you're viewing it as an object do absolutely nothing for the silhouette. So that is just a waste of polygons. We don't need them. Next up, the polygons are not uniform. So these here have been merged in a sort of really bad way. These long thin triangles will not deform nicely on a mesh, not that our mesh needs to deform. They will also often cause issues with the UV map, because parts of the texture are trying to fit into a really small part of a polygon. That can cause a range of problems. There are a bunch of, ever so slightly beveled towards the bottom of the candle. If you're wanting to give the candle a slight bulge at the bottom because the wax is melted on, sure, but having that dense amount of polygons in an object where you're not going to see that from, a certain distance away, it's just a waste of polygons again. Also, the fact that these are very, very dense here, and then, less dense here, and then the whole thing was sort of not needed in the first place, as opposed to the dish, where for the most part we have the relatively evenly sized polygons, as we've mentioned before. Also, this will make the model not symmetrical as well as being unnecessary, because whilst there is symmetry going on in a radial fashion around the z-axis, this part here is not symmetrical, and we'll see the results of that when we look at the sculpted model later on. Once again, not needed. There's ever so slight bevels. These help the smoothing groups, and we'll be looking more at this kind of modeling technique for the high poly models, but for a low poly model, you want to fix the smoothing groups either with marking the edges, a normal map, or splitting the texture off. Having these different loops at the top and bottom to help the normals shade as sharp around that edge, whilst it looks nice, again, complete waste of polys, because that poly is going to be very, very small on the screen, and the transition could be handled by the normal map anyway. A few other things. So we've got a large n-gon here, which has all these different edges along the bottom, and then the 4 edges along the top. So obviously want to avoid that kind of thing. The ring around here is completely broken, so if we try to select the ring of polys around there, it'll stop as soon as it can't find the next part of the loop. Avoid that wherever possible. Beveling an edge, in some cases you may want to bevel an edge on the low poly model, but having that many iterations to make it that smooth, obviously not great that close up. And also, even if you were that close up, having all the smoothness on this edge as opposed to the much bigger curve, you probably want to assign more polys to that curve rather than this one here. Also worth noting, we've got a couple of faces here. So this face has just straight up been extruded from the other edges and doesn't connect to anything. Obviously avoid that wherever you can. Areas where a plane sticking out by itself may be useful would be if you're using a texture with an alpha to do something like hair or bushes or leaves. We won't really be getting into that for assignment 1, so don't worry about it too much. So yeah, generally try to avoid a face that's just sticking out like that. Have, closed surfaces wherever applicable. Also, if we zoom in far enough and see inside the mesh, I've actually modeled inside the base of the candle holder and the bottom of the candle itself. So, whilst one is sitting in the other, and that's what a candle does, all those polys on the inside, which, hide also works for polys, and Alt-H to unhide them. Whilst that might technically be accurate, that, the candle holder would have an inside at the top and the bottom of the candle would have a base, both of those layers are useless because we're not actually going to see them. Where you would do this is if the candle itself was an interactable object and the player was able to take it out. At that point you would need to see the base of the candle and you would need to see the inside of the candle holder. However, if it's just the one object and it's static, you won't need to see all that interior detail because it'll never even show up in the rendering. The wick up the top here, primarily a triangular shape, so these edges along here have added a little tiny bit of detail. Again, that far back, you're never going to see it. And also, that is on the shortest part of it. So you probably, if you were going to add any more loops to this, want to add an extra loop along the vertical lines here to split that up and have that curve be a bit nicer, because that is the larger part of that mesh. More of the same. There's been a bevel to curve this nicely and curve this nicely. Not just nicely, but that would be complete overkill, generally speaking. And then this part has been left. So jumping back to the silhouette, all these polys do help the silhouette ever so slightly on the two curved parts, but because it hasn't been done in a uniform fashion, we still see the straight edge. So just a reminder that if you're trying to get a continuous shape, keep a continuous amount of detail and have the polygons relatively evenly sized and spaced out. A few more minor things. This glob of wax down the bottom here, If you were going to do a smaller detail like this, you know, it may be acceptable to do here and there, depending on whether, it can add a bit to it. This is also a mess of triangles. If it's something this small, having it come out to a few triangles might be fine. Once again, you don't need complete perfect edge loops absolutely everywhere. But again, having it transition, you would want to do it in a smoother way than this. And also, it's just the wax in the one little area. The rest of the candle is, doesn't have that same level of detail. So it might be, from a poly count point of view, okay to have a little bit more detail in one or two spots. But if one area is really standing out as detailed and the rest of them aren't, then it's probably better to just have an even amount of detail overall in the model and then try and get some of that detail back in the texture. Another thing to mention is, as well as being an n-gon on the bottom here, you can see that the shading doesn't quite line up. This is because the normals have been flipped. Normals are very important, not only just for baking the normal map, but if this is facing the wrong way as a face, chances are in a game engine that it will just show up as transparent because it's showing the back of that face, and game engines tend to render one side of a face only. So there are a few ways to check the normals, make sure everything's okay. If we go to the viewport overlays, you will see that there are a number of options. If we select face orientation, that will give us a very clear indication of blue being correct, red being incorrect, or just red being flipped, but for our purposes incorrect. If you turn that off, there's also the option to select face normals, and a size next to that. Because we've got quite a small object, we might want to do 0.01, and you will see that there is, from the perpendicular of that face, a little blue line showing the outward direction of all of them and none on that one there. So if we were to go to mesh, we'll have our mesh menu, range of options here. From this menu, select normals, flip. This will then put the resulting normal outwards, much like everything else. And again, just to double check if you need to, face orientation, that is matching with everything else. So that is good. So we can then turn off normals and turn off face orientation. So a range of things that are wrong with this particular model, even though for all intents and purposes it is very, very similar in shape to the other mesh, which is good. Also a minor thing, but worth reminding, it is also named cylinder.001 instead of something logical like candlestick, so naming conventions are important. Just briefly, if we were to look at the sculpted version. So we're not going to spend too long on this one. First of all, way too many tries. So we can see it's over 100,000, whereas the good one that we had before was much closer to 500. So quite a difference there. Also, just deselect those. The long, thin triangles here might be much more of an issue if we were to try and UV unwrap that. We would get a lot of stretching and, pixels being half a pixel to try and get onto a polygon, which never quite looks right. So not to dwell on this model too long, but whilst it is a very nice shape and for the most part very clean, way too detailed to use as our low poly mesh. Also, just the other thing I wanted to raise while we were looking at this particular mesh here, other than the fact that most of it's triangulated, it's done a fairly even job of the base. Again, just way too dense, and there's no real edge flow to help with the editing. The detailing on the center up the top here, symmetry was fine for that because the pivot point was centered. So radial symmetry, I was able to draw on that one pattern and it's sculpted on the pattern all the other times around. The pivot point was deliberately broken when I sculpted the lower part. So you can see that it's sculpted some radial symmetry, but because the pivot point was ever so slightly forward, when it gets here, it misses certain parts because the brush is too far that way. And on the back, same thing again. Radial symmetry didn't quite work because the pivot point was offset, so it missed parts of it completely, which is, again, not what you want. So that is why pivot points are important, even if it's not so important when you're working on your specific low poly model. It can be very important later on down the track for using the texturing and sculpting and just making sure that the model is going to be nice to use for everyone else further down the pipeline as well. So that's pretty much all I wanted to show with that mesh there. So from now, we will just go back to the good candlestick and begin to look at the process of UV unwrapping. UV unwrapping is something we took a brief look at in the first lecture as part of the general overview for the asset pipeline process, but I didn't actually show you anything on technically how to do the unwrapping. So what we're going to want to do is select the object, go to UV editing mode. The object is real tiny again, so you can either zoom in or select all and hit numpad, full stop. I believe I need to turn screencast keys on again because I'm in another section. Again, that's just something I need to do for the video. You don't need to worry about that plugin. That's just showing, again, the key presses in the lower left there. So I have all faces selected. If I was to hit U, this brings up the UV unwrapping menu. If we just click the very tempting first option, unwrap, it's done something, but that has not unwrapped in a way that we want. Certain sections, like this, because we've already split it off, as mentioned previously in the video, that works perfectly fine to just stamp down. It has a shape, it has edges, it has a boundary, and yeah, works perfectly fine as is. If we were to select here, however, what this has done is tried to have an inner circle and an outer circle. So this is going to be quite stretched when we look at it. So what we would want to do here is select an edge, Control E, which will bring up our edge menu. Again, extruding, beveling, certain tools you may recognize that we've done before in other ways. The edge menu is very specific to edit mode and very specific to edges. What we can do here is mark seam. So a seam shows up as bright red, and if we hit the L key to select that linked part of the mesh, U for unwrap, that has now unwrapped it in a way that treats that as a border edge and lays the polys flat on the surface over there, which is far more what we want. Similarly, if we were to select L here, it's done its best, but again, it's a cylinder with no boundary, effectively, so we will also need to give that a seam. On an object like this, the seam can't really hide anywhere, but broadly speaking, if you can hide the seam, you know, tucked underneath somewhere or on an area of the model that's going to be seen less, you want to get the seams as out of the way as possible. However, if it's on a cylinder that's rather uniform and rather upright, we're going to see all of that, so we'll just have to put it somewhere and make sure we give it enough attention in the texture painting that then doesn't show up as a horrible edge when in the game engine. So U again, unwrap, and that's done a much better job. If we were to select all faces again, for starters, you'll notice that because we've been unwrapping pieces individually, that then ignores the scale and just starts overlapping pieces over each other. You don't want this. So what you can do is select the UVs up the top here and click Pack Islands. So that will take everything at its current scale and pack it into a sheet so that nothing is overlapping. There is also the option down here for the margin. That will be how much of a margin there is between each item. This is also handy for when we're baking textures. It'll give a bit of a margin for pixels to spill out from each island, and it helps mask the seams in Engine. So whilst setting that to 0 will give you the most tightly packed UV map, leaving a bit of a buffer here and there is good and will generally help our process. However, there's still plenty going on, and we are far from done with unwrapping this particular model. So once again, everything selected, U for unwrap. There are a few different options here. Smart UV Project gives us the option to pack via an angle. This can be very useful, particularly for background elements you're not going to get particularly close to, because if I was to give that a little bit of a margin, and then click OK, that has automatically done most of what we want. However, when we get to the base here, we can see that some of the areas it's treated slightly differently, even though they've had the same angle. So not perfect, but it can be a very quick way to lay things down for certain objects. Another option, if we were to go to the orthographic view, just hit 1, U, cylinder projection, and again we've got the options down here to tweak a few things. So if we have that set to scale to bounds, we will notice that it's tried to wrap a cylinder around the object, which for parts of the mesh, like the candle and anything you can see sort of along the z-axis, other than overlapping them, it's done an okay job with certain very specific parts. However, where you can see these dots over the top of each other, it's given absolutely no texture space to anything that is on the horizontal, because once again it's just literally tried to put a cylinder around it, and that has not worked for anything that is inside, because it is flat from the orthographic view. So again, cylindrical mapping can help as a starting point for certain objects, but shouldn't be relied on, particularly for more complex shapes. So what I'll do now is just quickly run through and do this properly. So edges selected, Control E, mark seam. So with the little wick, the triangle up top, we'll also need this one here, mark seam. So now each of those faces can be laid flat. This disc part up the top here is continuous and again is split. Let's just grab those there. That is split, so that will unwrap fine. This already has a seam. This here is flat, so that'll unwrap fine. This has a seam. This is flat, so it'll unwrap fine. Noticing a pattern here. Control E, mark seam. So that cylinder is now fine. That's flat. Control E, mark seam. Keeping all the seams sort of roughly in the same spot will just make it easier to visually check, both when we're texture painting and once it's in the actual engine itself. So that's fine. Now the dish, probably want to put the seam here, so mark seam there. Although that will cause a little bit of extra stretching when the mesh tries to go back in on itself, so perhaps it's slightly better to put it here. And with the handle, we can hide the seam underneath there, so it'll still be visible from certain angles, but it's much more hidden than it was before. So I think that is all the seams we need. Select all, U, unwrap, and now that is looking much better. Things are still rather loosely packed, so if we were to hit L, we can select an island at a time, or with these selection options up here, if we can change that to island select mode, it'll select one contiguous piece of the UV layout at a time. Again, A or Alt A to select all or deselect all. That works in this menu as well. Something you also may want to check is average island scale. So if you've just done the unwrap once, it'll tend to do that for you. However, if we know that this part of the candle is getting way more texture space than everything else, because it's far bigger, if we go to UV average island scale, that will put everything so that when it's laid flat, it should be using the right amount of texture for that part of the mesh as opposed to that part of the mesh. So, if you were to have a tileable bump map put over the top, that tileable map would look the same scale on each part there. An easy way to show that is to go Image, New, and then instead of blank, we can do UV Grid. This doesn't immediately show up in the viewport. We will need to do a couple of steps to get that to happen. One is to put the viewport shading onto that third tab there. This will then do an approximate version of the material. So at the moment, this object has no material. So if we were to click New, we've got material.001. We would call that candlestick so that it has a name. And to keep things simple for now, we would then go to the base color here, add an input for the base color, which is this menu out here, and image texture. And because we've created this image here, which we can go from untitled to UV grid, that will then be selectable from this little drop down menu here. So as you can see, that is all uniformly scaled, which is what we want. Again, if we were to deliberately make this part way too big, you would see that the texture is going to get far smaller details because it's a much larger space on the UV map, whereas everything else will be uniform as we left it. So if we were to select all UV average island scale, and then obviously we want to keep everything within the 0 to 1 square, which we mentioned in the initial overview, but worth mentioning again now, UV pack islands. So now everything fits within the 0 to 1 square. Everything is a uniform amount of texture space, and that is generally pretty good. In an actual game, this would have a bit too much wasted texture space, so we would spend a bit more time maybe splitting one or two objects up a little further, just so it packs in nicer, because any of this texture here that doesn't have the orange over it, because it's not assigned to any faces, is effectively wasted. It's just taking up RAM. If it's easier, like we saw with the dagger in the first video, it might be such a long thin mesh that you assign half of that texture to that object and then merge the textures with another similar smaller object that would appear in the same scene. For assignment 1, I would like to see, minimal amount of texture wastage, but it's more important that everything is uniform and there's not a whole lot of stretching going on. So an unwrap like this is not ideal, but it would be fine for assignment 1. Generally speaking, though, if you were to pursue this further, like I said, you will want to make sure the texture is a bit more tightly packed and therefore a bit more efficient. However, that concludes the introduction to UV unwrapping. It's often seen as not the most fun part of the modeling and texturing process, but it is a very necessary part, and Blender has a range of tools, as we've just seen, to make that fairly streamlined. That also concludes the lecture for today. For the practicals, there will be certain objects that have no unwrap that we can then take through the unwrapping process, as well as just working on your models for assignment 1 and getting some more progress done there. If you have any questions, let me know. Otherwise, that concludes this video. Thank you very much.